Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter coordination compounds. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that an octahedral complex is formed when hybrid orbitals of the following type are involved. So as you know that so if it is an octahedral complex, so the rule is that depending on the ligand, nature of the ligand, the octahedral complex can be of two types. Octahedral complex is of two kinds. First one is the inner orbital complex. Inner orbital complex, sorry, one is the inner orbital complex, which is the D2sp3 hybridization, and which is formed when there is a influence of a strong l- ligand. So it is formed when the ligand is strong, when the ligand is a strong ligand. And the second type is the outer orbital complex, which is the sp3d2 hybridization, which is formed when there is influence of a weak ligand. So which is formed when the ligand is weak. So here D2sp3 can be formed when there is an octahedral complex. So option A is the correct answer. Then here it is told a complex compound in which the oxidation number of the metal is 0. So here the rule is that CO, the oxidation number of the metal is 0. So CO is a neutral ligand. CO, as you know, it is a neutral ligand. Hence, hence the oxidation state, hence the oxidation number of nickel in the complex, in the complex NiCO4, that will be 0. So option A is the correct answer. And here it is told ligand can also be regarded as a so uh, ligand will act as a Lewis base, since why it will give e- e- electrons. So since a ligand will donate an electron pair to the central atom, so the ligand will donate an electron pair to the m- m- metal atom in a complex ion. So it is acting as a Lewis base. So it acts as a Lewis base. So option A is the correct answer. Then the IUPAC name of this complex ion is which is CONH3 whole 5 ONO 2 plus. So here, um, so it is pentaamine, obviously, since here five amine groups are linked. So it is pentaamine, and this is nitrito, which is ONO group. So it is nitrito, nitrito, cobalt 3. And since why here cobalt is in 3 plus in plus 3 oxidation state, since why ONO has got minus 1 oxidation state, which is the nitrito ion. So it is pentamine nitrito cobalt 3 ion. So option A is the correct answer. Then the IUPAC name of K2NiCN4 is, so it means that NiCN4 here it is 2 minus ion, since why potassium is in plus 1 oxidation state. So NiCN4 2 minus it is, and cyanide ligand, as we know that it has minus 1 oxidation state. So it means that NiCN4, so here nickel is in plus 2 oxidation state. So we can say the name will be potassium, potassium tetracyano, tetracyano nickelate, nickelate. And since nickel is in plus 2 oxidation state, so its valency is 2. So it means that option A is the correct answer. Then it is told which of the following is wrongly matched. So here CuNH3 whole 4 2 plus. So here, so it is a, so it is having square planar shape, since it is DsP2 hybridization. It is square planar. And NiCO4, NiCO4. So here, as we know that CO is a neutral ligand. CO is a neutral ligand. And in case of FeCN6, FeCN6 3 minus, here iron is in 3 plus oxidation state, since cyanide has got minus 1 oxidation state. Minus 1 is the charge of Cn. So here, so here, as we know that cyanide is a strong ligand. Cyanide is a strong ligand. So, so and so it means that FeCN6 3 minus, it is, it will form an inner orbital octahedral complex. It will form an inner orbital octahedral complex. So, so it means that it will, and since here 6 ligands is used, so obviously it will have an octahedral shape, octahedral complex. And so since Cn is a strong ligand and it is an inner orbital complex, so its hybridization will be D2sp3 hybridization, and not sp3 d2. So sp3 d2 will be formed if it is an outer orbital complex, which will be formed when the ligand is weak, but here the ligand is strong. So it means that uh, option C is wrongly matched. So option C is the correct answer. Since it option C is wrongly matched. Then the IUPAC name of the complex CONH3 whole 4 Cl2 CONH3 whole 4 Cl2 Cl. So here it means that here CONH3 whole 4 Cl2, this is plus charge here, and here Cl minus is the charge. So chloride, as we know, it will have -1 oxidation state. So here CO is having +3 oxidation state. So the valency of cobalt is 3. So it is so therefore its name will be tetraamine tetraamine dichloro dichloro cobalt 3 chloride. So this will be the required IUPAC name. So option B is the correct answer. And since here amine, it starts with A and chloro starts with C, so amine group has got alphabetical seniority. So it means that the amine group should be written first, and then we should write the chloro group. Then it is told which of the following is a negatively charged bidentate ligand. Negatively charged bidentate ligand. So dimethyl glyoxymeto, dimethyl glyoxymeto, its its structure is like this. Minus says, sorry, the single bond here. It is called dimethyl glyoxymeto. So it is a negatively charged bidentate ligand, since it has got it has got -2 charge, but here it can link with this oxygen atom also, or it can link with this oxygen atom also. So it is a bidentate ligand. So it is a negatively charged bidentate ligand. Then we have cyano, which is Cn minus, which is the cyano. So it is a negatively charged, and it has negative charge. So it is a negatively charged ligand. So it is negatively charged unidentate ligand. Unidentate ligand, since it can link with only one side. It means that with only one nitrogen atom. And in case of ethylene diamine, it is CH2, CH2, then this is NH2, NH2. So it is called ethylene diamine. Ethylene diamine. So here it has got two lone pairs on the nitrogen atoms. So it is also a bidentate ligand, since it can link with this oxygen atom, or it can link with this nitrogen atom with the central atom. So it is neutral, it is not having any net charge, so it is a neutral bidentate ligand. Neutral bidentate. So bidentate, it means that it can give the two lone pairs from two sides to the central atom. If from two sides it can give to the central atom, then it means that it is a bidentate l- l- ligand. And if it can give lone pair from only one side, then it is called as the um, unidentate l- l- ligand. So ethylene diamine is a neutral bidentate ligand. Then acet acetato acetato, that is CH3COO minus. So it is also a negatively charged unidentate ligand. Negatively charged unidentate ligand. So hence negatively charged bidentate ligand is only dimethyl glyoxymeto. So option A is the correct answer. Then here it is told the secondary valency of platinum in tetramine dichloro platinum chloride. So the so the formula will be, so the formula will be PTNH3 whole 4, since it is tetramine and dichloro, and platinum has got a +4 charge, +4 oxidation state, since here it is uh, written 4, and chloride will have -1 oxidation state. So the net charge on this complex ion is +2. So it means that here Cl2 will be required. So its name is tetramine dichloro platinum 4 chloride. So here the secondary valency of platinum is +4. So, so secondary valency means, so here the valency or the oxidation state of platinum is +4, but here secondary valencies are. So now secondary valency, it means the coordination number, it means the coordination number of the central metal atom. Coordination number of the central metal atom or ion. Now it means that it is linked with how many atoms. So it means, so the coordination number, it means that it is linked with, or it is bonded with how many surrounding atoms in the complex ion. So here Pt is linked with 4 ammonium atoms and or 4 ammonium groups, and 4 ligands are here, and 2 chloro 2 chloride links are here. So the net charge is +2 here. So coordination its coordination number is 6. So here coordination number of platinum is 6. So option D is the correct answer. So hence the secondary valency of platinum is 6. So option D is the answer. Uh, so here it is told that the atomic number of cobalt is 27. The EAN of cobalt in sodium this in this complex is how much? So now, therefore, EAN it stands for the effective atomic number. Okay. EAN means the effective atomic number. So now the formula to find EAN is the atomic number uh, minus the oxidation state of the central atom or the central m- metal atom plus the l- ligands number of ligands times the number of e- electrons donated by each ligand, number of electrons donated by each ligand. So now here so now here the ion is CONO2 whole 4 Cl2 3 minus. Since here it is Na3, so 3 Na plus ions is linked with this. So its charge is -3. Now, as you know that NO2 has got -1 charge and Cl2 also has got -1 charge. So the oxidation state for cobalt is +3. Now, therefore, the EAN value for cobalt, that will be the atomic number, which is 27, then minus the oxidation state, that is +3, then plus the number of ligands, that is 6, into the number of electrons donated by each ligand, that is 1. So it is 27 plus 6 minus 3, that is 27 plus 3, that is 30. So is EN value for cobalt is 30. So it means that none of the options are correct. Then it is told that a group of atoms can function as a ligand only when a group of atoms can function as a ligand only when it has a unshared electron pair. So only if it has got a lone pair of only if the ligand, only if the group of atoms, only if the group of atoms has a lone pair, or I can say unshared pair of electrons, then only it can function as a ligand in a metal complex. Then only it can function as a ligand in a metal complex. So option B is the correct answer. So actually in the previous one here, we have to, so each l- ligand will donate an electron pair. So it means that each ligand will donate two electrons. So it should be 6 into 2. So it should be plus 12 minus 3. So it should be 27 plus 9, which is equals to 36. So it means that here option C is the correct answer. So it means the EAN value for cobalt is 36. And here it is told correct statement is uh, correct statement is that C CONH3 whole 6 CONH3 whole 6 2 plus. So here the charge on cobalt is 2 plus. So CO2 plus, uh, the electronic configuration for CO2 plus, that will be argon 4s03d7. So it means that it has got three unpaired electrons. It has got three unpaired electrons. So it is paramagnetic. So hence it is paramagnetic. And in MnBr4 2 minus, the shape is tetrahedral. So that is also true. Since why Mn, here Mn is in 2 plus state. So Mn2 plus, the electronic configuration for Mn2 plus will be argon 4s03d5 and of and obviously 4p0. So it can have sp3 hybridization, that is tetrahedral shape it can have. Tetrahedral, since here 4 surrounding Br minus atoms are linked with Mn2 plus. 4 Br minus atoms will donate the electron pair to Mn2 plus. Then option C is COBr2En2 exhibits linkage isomerism, which is wrong, since why it will exhibit geometrical isomerism. Cis and trans isomers will be formed. which is one is CO En Br minus that will donate electrons. And as you know that En is a bidentate ligand. En is a bidentate ligand. So it will give, so it has two lone pairs which it can donate. Since it is a bidentate ligand, and Br minus is a unidentate ligand. So this one will be the trans isomer, of COBr2En2, and CO, if the two En are on the same side, then here the cis isomer will be formed. So it means that COBr2En2 minus ion, so it will exhibit uh, geometrical isomerism. It will exhibit geometrical isomerism. Option D is that NiNH3 whole 6 2 plus is an inner orbital complex. So here NH3, as we know, it is a weak ligand. It is not a strong ligand. It is a weak ligand. So hence complex, outer orbital octahedral complex will be formed. Since here we have six ligands of NH3 with Ni2 plus. So it is an outer orbital octahedral complex. So hence the so it will have sp3 d2 hybridization and not d2 sp3 hybridization. If a strong ligand is there, then we will have d2 sp3 hybridization and it will be an inner orbital complex. But here it is outer orbital complex. So C and D are wrong statements, but A and B are correct statements. So A and B both are correct options. Then it is told in which one of the pairs of ions given there is an ion that forms a coordination compound with both aqueous sodium hydroxide and ammonia, and another ion that forms a coordination compound only with aqueous sodium hydroxide. So in which of the pairs of ions given there is an ion that forms a coordination compound with both, so it forms coordination compound with both aqueous sodium hydroxide and ammonia, and another ion that forms a coordination compound only with aqueous sodium hydroxide. So now the rule is that zinc ion Zn2 plus ion reacts with reacts with both aqueous sodium hydroxide and NH3 to form coordination compounds. To form coordination compounds, which is Zn2 plus will react with 4 NaOH to form ZnOH whole 4 2 minus ion plus 4 Na plus ion. And zinc ion can react with NH3 also to form ZnNH3 whole 4 2 plus ion. Now, but Al3 plus ion, Al3 plus ion, it reacts with only NaOH, reacts with only sodium hydroxide in the aqueous solution to form a coordination complex, which is Al3 plus reacts with 4 NaOH to give AlOH whole 4 minus ion and plus 4 Na plus. So here, so it means that Al3 plus will react with only NaOH and Zn2 plus will react with both NaOH and NH3. So option B is the correct answer. Then it is told the complex ion having minimum magnitude of delta naught CS CFSE. CFSE means the crystal field stabilization uh, energy. So the so delta naught is also called CFSE, which is its full form is crystal field stabilization energy. So now the rule is that it is the amount of gain in the energy. It is the gain in the energy achieved, which is achieved by filling of electrons in the orbitals in the orbitals of the central atom. So, and the value of this crystal field, the the value of this crystal field stabilization energy, it depends on the number of ligands which are attached to the central atom and the nature of the ligands also, and also on the geometry of the metal complex, also on the geometry of the coordination complex. So here, so if the crystal field stabilization energy is negative, then only the complex will be a stable complex. Then only the complex is stable, else it is unstable. So it means the complex ion having minimum magnitude of CFSE, it means that which is the most stable complex that will have the minimum value of stabilization energy. So here we have to find out which one is the most stable coordination complex. So here the rule is the rule is that the magnitude of the crystal field stabilization energy follows the order, that is, with, if chloride is the ligand, then it is the least, then H2O, then NH3, and if it is cyanide, then it is the highest value of CFC. So here it means that the chloride ligand will have the minimum value of the crystal field stabilization energy. So it means that COCl 3 will have the minimum CFSE. So option D is the correct answer. Then it is told which of the following w- will be able to show geometrical isomerism. So the rule is that tetrahedral shapes, tetrahedral complexes, tetrahedral complexes will not show geometrical uh, isomerism. Tetrahedral complexes will not show geometrical isomerism. Only square planars can show. But here, since three ligands are similar, since if three ligands are same, then it cannot show geometrical isomerism. So the rule is that square planar metallic complexes of the type Ma3b, they have the l- three ligands are same. So here the these types will not show geometrical isomerism. Geometrical isomerism, but um, MABCD will obviously show, since here all four ligands are different. All four ligands are different, so hence it will show geometrical isomerism. So hence the complexes, square planar complexes of type MABCD will show geometrical isomerism. So option D is the correct answer. Then it is told that how many ions per m- molecule are pro- are produced in the solution when more salt is dissolved in excess of water. So now more salt more salt is ferrous sulfate and ammonium sulfate, ferrous sulfate, ammonium sulfate, 6H2O. So if it is dissolved in excess of w- water, If it is dissolved in excess of water, then it will form the FeSO4 ferrous sulfate, and or it means here ions will be formed. The Fe2 plus ions will be formed, and two NH4 plus ions will be formed, and two sulfate ions will be also formed, and 6H2O is there. Okay, so it means that uh, 5 ions per molecule will be formed, since it is 2 plus 2 plus 1. So 2 plus 2 plus 1 means 5 ions per molecule will be pro- produced. 5 ions per molecule will be produced. So option A is the correct answer. Then here it is told the number of isomers possible for the octahedral complex COCl2 NH3 whole twice plus is. The number of isomers possible for the octahedral complex this is. So En, as you know, that is a bidentate ligand. En is a bidentate ligand, and Cl and NH3 they are unidentate ligands. So CO, then En, then Cl2, Cl2 and NH3 whole 2. So here it means the shape will be, so it can form the isomer which is trans with respect to chloride, and then you can have CO, En, and NH3, NH3, Cl, Cl. Now this is also an isomer which is trans with respect to ammonia, NH3, and this one we can say NCl. So here the two chlorines are on the same side. So here it is cis with respect to Cl or with ammonia also. And its mirror image I can also form, which is Cl, Cl, NH3, NH3 and En. So so these both isomers are cis with respect to chlorine and ammonia. One is the L isomer, and one is the D isomer, L and D. Since why they are the stereo isomers, since it is they are optically active. Since this isomer is an optically active isomer, so hence four isomers are possible with this octahedral complex. So four isomers are possible with this octahedral complex. So option D is the correct answer. Now it is told that CO is a stronger ligand than Cl minus because CO is a stronger ligand than Cl minus because the reason is that CO is a pi donor ligand. It means that it will donate pi electrons. So it is a pi donor ligand since it donates the pi electrons. So since it is a pi donor ligand, so it acts as a stronger ligand than Cl minus. So it acts as a stronger ligand than the chloride. So option B is the correct answer. Since as you know that CO has got pi bonds. It has got three, it has got two pi bonds. Then it is told which of the following sequence is correct regarding field strength of ligands at as per spectrochemical series. So as per the spectrochemical series, as per the spectrochemical series, the order of the strength, the increasing order of the strength of ligands is the increasing order of strength of the ligands is given as that is SCN minus less than F minus less than Cn minus less than CO. So it means that CO is the strongest ligand and the thiocyanate ion is called thiocyanate ion. It is the weakest ligand and cyanide cyan, cyanide ion is weaker than CO. So option A is the correct answer. As per IUPAC norms, the name of the complex is, so it is obviously chloro, it is torido, bis, ethane 1,2 diamine. Since why this En, it is called ethane 1,2 diamine. This CH2 NH2 CH2 NH2. So it is a bidentate ligand. So it is ethane 1,2 diamine, and since here two groups of En has been used, so this bis should be used as the prefix. Then we have nitro group, and here the nitro will give the electron pair from the oxygen atom. So here we should write nitro O cobalt And here cobalt also in CO En2ONO Cl. So here the net charge of this complex is -1, and chloride is in -1 oxidation state, ONO is in -1 oxidation state. So it is plus here and Cl minus. So here cobalt is in +3 oxidation state. So the valency of cobalt is 3 here, and then chloride is also attached. So it will be chloride. So it means that option A is the correct IUPAC name of this coordination complex. Then it is told that the coordination number and the oxidation state of the element M. Coordination number and the oxidation state of the element M in the complex MEN2C2O4 NO2. Now C2O4, it is the 2 minus ion, which is called as the oxalate ion. Oxalate is also a bidentate ligand. It is also a bidentate ligand. Since why C2O4 2 minus is like this, C2CO means, and En2, En is also is ethane 1,2 diamine. So it means that it is also a bidentate ligand, since here two amine groups are attached to the carbon, to two adjacent carbons. So it is also a bidentate ligand. So the oxidation state, now here the oxidation state is 2 minus for oxalate ion, and for NO2 it is -1. So here the net charge of this complex is +1. So it means that the metal ion is in +3 oxidation state. So it means the oxidation state of the metal ion M is +3, and the number coordination number is given as, since why it is MEN2C2O4. So En2, En and oxalate, they both are bidentate ligands. Hence, therefore, the coordination number of the metal atom M, that is 6. So it means the coordination number is 6 and the oxidation number is 3. So option C is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter um, coordination compounds. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos, or in the comments itself we shall clarify those doubts. And also please install our Sapience education application, where we shall upload some important questions based on the previous year KCET exam on every chapter of chemistry, which shall be obviously helpful for your exam. So thank you everyone. Bye.